What's up? This is my channel. I'm Professor Potato, and today we'll be going over the concept of a vector. Alright. Besides such magnitudes as temperature, mass, and so on, which are characterized by the assignment of a single number, and which are called scalars, there also occur in physics quantities which are not completely defined by specification of a single number. The most important group of these is characterized by the fact that besides magnitude, the direction of the quantity must also be given. If, for example, we prescribe that to an object located by means of its center of gravity, P, be given a displacement of 2 centimeters, then point P1 occupied by the object after displacement may be anywhere on the surface of a sphere with a radius of 2 centimeters, with a center at P. Like this first displacement point that goes to that. That's like the first vector. Alright. Two displacements of a point may be combined into a single equivalent displacement by a simple method. You just draw it out. You can make a triangle. You can use trig functions to solve for different things in it. Instead of moving from point P to P initial in a certain direction, then displacing in a new direction to P2, it might have been moved directly along the third side using a triangle here. Since this process can be repeated, we can place the origin P in the origin of the coordinate system and move the point first along the x-axis to P1, a distance A, then parallel to y on the axis of B to P2, and finally from here parallel to the z-axis P1. Instead we might have moved P at all P's at once in the direction of P sub P. Alright, then we use the formula D root A squared plus B squared plus C squared. We see then that the displacement of P is uniquely determined by specifying three numbers, A, B, and C. These are called vector components of the displacement. A large number of physical quantities follow the same law of combination as the displacement of a point, and may also be represented by a vector diagrammatically. So you can just draw this at points. Here are more examples of different things we'll be talking about in further videos while we learn vectors. Alright, two vectors are said to be equal if they have identical with respect to both direction and magnitude. That's just basic derivative if it respects with like a respect to time, except here we're respecting magnitude or length. Physical quantities which are altered by pure displacement are therefore not immediately representable by vectors. To this class belongs, for example, the force acting as a rigid body capable of rotating around an axis. Parallel displacement alters the level arm of the force and thus changes in its effect, not vect. I don't know what I'm saying. It can be noted further that every physical quantity which is represented uniquely by a directed line segment may be treated as a vector. It is also necessary to investigate whether this quantity follows the law of composition of a rigid body. That's all I have for today's video. Sorry it's a little bit weird. I've tried to film this. I'm not very good at this yet, but I'll get the hang of it. I'm signing off.